In multi-step reactions, the slowest step is going to be the rate-determining step, which is to say, the slowest step in a reaction is the one that's most important in determining the overall rate of the reaction. On the screen are two reaction coordinate diagrams for two-step reactions. On the left is a reaction where the second step is the rate-determining step. You can tell which step is the rate-determining step just by looking at the reaction coordinate diagram. The step with the largest activation energy requires more energy to happen and is therefore less likely to happen, and therefore happens more slowly. In the two-step reaction shown on the right-hand side of the screen, the first step is rate-determining, and the first step is the slowest because it has the larger activation energy. Whichever step is slower is said to be the rate-determining step, and in practice what that means is the rate-determining step is the step that determines the rate law. We'll look at an example where the first step is slowest and the second step is fast. An example of this type of reaction is the reaction of NO2 with CO. This reaction has a mechanism with two elementary steps. The first step is slow, and the second step is fast. Because the second step happens quickly, we can ignore its effect on the overall rate of reaction. The first step, the slow step, acts as a bottleneck, and it's the one that we have to worry about. Because it's an elementary reaction, we can just write the rate law based on the stoichiometry. And in this example, the exponent for the NO2 is 2 because there are two NO2s in the reaction. And the K is the rate constant for that slow reaction. Writing a rate law for a reaction where the second step is the slow one is considerably more difficult, and it requires you to know something about chemical equilibria. And even still, that type of reaction is fairly straightforward. In reality, some of these reactions can have side reactions, or they can have relatively long-lived intermediates that can alter the rate of the reactions. And the situations can only get more complicated.